Good day everyone. We are Group 5 presenting our Bluetooth controlled car system. So our car system contains or includes three main components. These are Arduino Nano as our main microcontroller and L298N motor driver. And lastly, HC05 Bluetooth module. Next slide please. So for our system overview, for introduction, the Bluetooth controlled car is an autonomous vehicle prototype built for our CPE 417 microprocessors. So our purpose is to demonstrate wireless motor control using serial Bluetooth communication with an Arduino microcontroller. So under here is the input process output diagram. And first, in our input diagram, contains phone where the inputs will come from. Here are the inputs: forward, backwards, left, right, and stop. In stop. Moving on, the imputed values will go to the process diagram, especially the Arduino Nano, where mainly it receives and decides what our output components will do. And lastly, our output diagram contains motor drivers or it powers the drive motors for our output actions.
Now I will explain the hardware components and pin connection used in this project. First is the main controller of the system is the Arduino Nano. It acts as the brain of the robot by receiving Bluetooth commands and sending control signals to the motor driver. Next, we use the HC05 Bluetooth module for wireless communication. This module connects to the mobile phone and receive commands such as forward, backward, left, right, and stop. The L298N motor driver is responsible for controlling the two DC motors. It allows the Arduino to control both the direction and speed of the motors using digital and PWM signals. The DC motors are connected to the wheels of the robot and of the car and provides movement for the system. An external battery is used to power the motors. And for the pin connections, Arduino pins D6, D5, D3, and D11 are connected to the L298 motor driver inputs 1 to 4, and these pins control the forward and backward movement. HC05 Bluetooth module uses pin D9 and D10 for communication. And lastly is the voltage divider is connected to the HC05RXD pin because the Bluetooth module works on the 3.3 volt node logic while the Arduino output is 5 volts.
Now let's move on to our program flow. The program begins in the setup function, where the Arduino initializes the motor control pins and establishes communication with the Bluetooth module at a baud rate of 9600, which is considered the standard. After initialization, the system continuously checks whether Bluetooth data is available using that available. When a command is received from the connected device, the Arduino reads the character through the dot read. Each character corresponds to a specific movement instruction such as F, forward, B, backward, L, left, R, right, or S, I, stop. The program then uses a switch command statement to determine which action should be executed. Based on the received command, the Arduino activates the appropriate motor function to control the robot's movement in real time. Next slide, please. The command handling section of the code is responsible for interpreting Bluetooth inputs and translating them into movement actions. The software serial HC05 and 910 line, it creates a communication channel between the Arduino and the module. Inside the loop function, the Arduino continuously checks for incoming Bluetooth data. Once a character is received, the switch command statement evaluates the command and executes the corresponding motor function. such as, yun nga, kanina, forward, backward, turn left, turn right, o stop. The robot's movement direction is controlled using digital right, while motor speed is adjusted through analog right using PWM signals. This structure allows the robot to respond quickly and efficiently to wireless commands sent by the user.
So as for system demonstration, the first part is to pair the HC05 or the Bluetooth module. Go to the phone, Bluetooth settings, then pair it to the HC05, which is the Bluetooth module. Then, after pairing, the blinking on the Bluetooth module will then stop. So the second part is to open the controller app, launch the Bluetooth RS controller, or any similar app that uses the Bluetooth. For our third step is to power the car, connect the battery to the L9 L298N and ensure the Arduino Nano is powered on so the Bluetooth will be used. And lastly, execute all the commands. Test forward, backward, left, right, and stop. And verify if it's smooth and or it has the correct response. Next slide. Uh, as for testing and troubleshooting, the first part is that the Bluetooth module doesn't get paired. So the solutions that we did are we paired the Bluetooth module via phone settings before using the app. Then the second one is that the motors are not responding to the command, so we rewrote the code using direct analog write and pin control. Direct analog write pin control. The third one is that we used the AF motor library but still had no motor shield. So we replaced the AF motor with software serial plus L298 and wiring. The fourth one is that we had pin conflicts with the original servo slash ultrasonic code. So we preserved the motor pins prior from the code. And lastly, the HC05 RXT receiving 5-volt signals. So it has a 3.3 volt logic mismatch. So the solution that we did is that we added voltage divider on the TX RXT line. That's it.
Next slide, please. Now, moving on to the evaluation of our system, I am happy to report that we successfully met all of our functionally all 5 commands forward, backward, left, right, and stop. Execute exactly as intended based on the phone app's input. In terms of efficiency, the system is highly responsive and communication over Bluetooth is near instant. And we did optimize our Bluetooth car very well. Unfortunately, we did not manage to get onto the final two of our race, but we do have our functionality, efficiency, and reliability stable, good, and met. So, next slide, please. Looking at the innovations or for the future improvements, behind our build, we successfully adapted this our chassis from a previous obstacle avoidance project into a fully Bluetooth controlled system. We achieved this by writing a direct pin PWM control code which allowed us to bypass a bulky motor shield and libraries while retaining our original hardware pin mapping. And for future improvements, we have several exciting ideas. First, we want to reintegrate the ultrasonic sensor so the car can actively avoid obstacle even while being driven in Bluetooth mode. We also plan to add variable speed levels, develop our own custom mobile app featuring a joystick interface, but I don't think we're going to do that much since this is for future improvements and suggestion after all. So that's it for our meeting. Thank you.